Okay, so variance is another quantity discussed in 3.3 that is related directly to standard deviation. As a notation, variance is a lowercase letter v is used to symbolize a variance. As a formula, variance, as a definition, variance is just the square of the standard deviation. Now remember, my s, lowercase s, stand for standard deviation. So variance is defined to be the square of standard deviation. So now with this only formula to find variance, here's how we can quickly see an example of to find the variance here. So if you look into the first example, and once again we focus on dataset 4, So now here's the thing. So the formula here is telling me that variance is the square of standard deviation. So to find variance, the standard deviation we have found in the other video was 2.87. So variance is defined to be the square of standard deviation. So we just simply square that quantity, 2.87. So 2.87, and you square, and that gives me variance equals to 8.24, rounding to 2 decimal places. So that's how we find the variance. Now, to find variance, here's only one way how we can find the variance. Finding the variance this way in example 1, we are in the assumption that we already know the standard deviation before you can find the standard deviation. So here in this example 1, the situation here, the scenario here is we already know standard deviation, so that we can go back and find the variance. Now the formula, it's just, so this example here is naturally produced from that formula itself, the way how it's written. Now in the way how the formula for variance is written right here, it makes people think that we always have to find the standard deviation before we can find this variance. The answer is actually no. The truth is actually no. We don't have to always know the standard deviation before the variance. So let's try to reinvestigate the whole thing again. Still the same formula for finding variance, but here's how you can look at that wisely. So we're looking at dataset 4 again, okay? But this time, suppose that not knowing, let's assume that we are not knowing standard deviation already. Okay, assuming that we didn't know standard deviation yet, and we still want to find variance. Okay, we want to find variance. So here, variance in this way can just simply be found by, and let me point it out to you. So the variance, you just simply about 3/4 of the works to find standard deviation is the work to find variance. So here's what happens. First data value minus the mean value, square the difference, and there's only one time. Second data value, and it's a 3, minus the mean value, square the difference, there's 2 times of that square. Third data value minus the difference, there's only one time, 6 minus 6.27. So what you're seeing, as you're seeing what I'm doing up here, as you're seeing what I'm doing here in this video, I am just simply rework the standard deviation problem. And once again, it's all because we're assuming that we don't know the standard deviation yet. So we're still on our way to find the standard deviation. Three times, and last one, 10 minus 6.27 square, and 2 times. And then we're still going to divide all that sum here by 10. Remember, 1 less than the total. But here, this is where we stop. We stop right here, because here we're looking for this variance. Variance is, remember, it's the square of standard deviation. So if you want to proceed to find the standard deviation, all you have to do is take the square root of all that fraction, this huge, gigantic fraction right here. Otherwise, if you want to simply find the variance without knowing the standard deviation, here's how you do it. To find the variance, you just go ahead and work out your standard deviation problem, but then without the square root. Without the square root. So variance is, once again, according to calculation this way, then variance would be roughly equals to 8.21819. That's according to the calculator. So rounding that up to 2 decimal places, we have 2.82. And so you can see that the two answers doing the variance in two different ways are close enough to to accept the two different ways how you can find a variance. So variance that we found earlier, just simply by squaring the known standard deviation, is going to be just 8.24. Here we have long work here to find the variance without knowing the standard deviation, and the answer was a 2.82. I mean 8.22. They're about 0.02 differences.